Question 5 from the review, okay? A marble rolls off a flat desk 2 meters above the floor and hits the floor at a distance of 5 meters from the base of the desk. How fast was the marble rolling? Okay, a couple things here. This is a blast from the past, meaning that it's something that we've covered beforehand. This happens to be covered under projectiles. So, in this case, we need to recognize that we're talking about the velocity in the x is what we're trying to find. So the velocity in the x is equal to the distance in the x divided by time. Alright? Now, we have the distance in the x. 5 meters is the distance in the x, but we do not have a time. We do have a distance in the y, and if you'll remember, the distance in the y often let us solve for our time. So let me rewrite that. The distance in the y is equal to 2 meters. Okay, so what we're going to use is the distance in the y formula to solve for time. dy equals 1/2 ay t squared plus viyt. Alright, what is the initial velocity in the y going to be if it's dropped off the desk like this? Well, there wouldn't be any initial velocity in the y, so that goes to 0. We don't have to worry about it. So we're left with 2 is equal to 0.5 times 10 times t squared, and we're solving for t. So 2 divided by 5 equals t squared. Alright, which means that the square root of 0.4 equals t. And the square root of 0.4 is 0.63. 0.63 seconds. Okay, so this is our time. That goes back in up here. Vx is equal to 5 divided by 0.63. And 5 divided by 0.63 is 7.94. And so that would be the velocity that it rolled off the desk with, 7.94 meters per second. Moving on to question number 6. A cannon which fires a projectile at 80 meters per second is set up so that it fires at an angle of 30 degrees. How far away is the target? Well, we're assuming that the cannon then is this 80 meters per second. It's shot at an angle of 30 degrees, and we want to know how far away is the target, which would be, basically, we'd be looking for dx. And so, there we go. So we're looking for dx. Formula for dx really is just vx equals dx over t solved for dx. Well, in this case, dx would be equal to vx times t because we'd multiply the t up. So we're trying to solve this formula. Now, if you'll notice, I don't have either of these things right now. So I've got to do some solving. Alright, first thing we need to remember is that it's broken up like this. We have a velocity in the x, and we have a velocity in the y. Okay? Velocity in the x is equal to velocity, which is 80, cosine 30. Velocity in the y is equal to 80 sine 30. Which gives us these values for these two things. So Vx and Vy, and this is the initial velocity in the y, mind. Vx is equal to 80 cosine 30. And keep in mind, you need to make sure that you've got it in degrees and not radians. So 80 cosine 30 is 69 meters per second, and 80 sine 30 is 40 meters per second. Okay, next thing we need to know is, or need to remember, is if the initial velocity in the y is 40 meters per second, the final velocity in the y, way over here, is what? Well, if you'll remember, it should have been negative 40 meters per second, which gives us a way to solve this, because we need to find the time here. We now have a Vx, so if we wanted to, we could label this. We could say dx equals Vx, which is 69 times t, but we don't have a t yet, so that's kind of unfortunate. So what we've got to do is use the y stuff to find a time. Well, what you can do is you can go a is equal to Vfy minus Viy minus over t. And if you do this, you should get be able to solve for a time because we know what the time is here, and we know what the final velocity in the y. We know what the initial velocity in the y is. We know what a is. A is, remember, negative 10. VFY is negative 40. VFY is negative 40. VIY is 40. And divide that by t. So we get, bring t up, multiply t up, and divide by negative 10. So we get t is equal to negative 80 divided by negative 10, or t is equal to 8 seconds. So if t is equal to 8 seconds, that's what I'll plug in over here. So dx, it turns out, is equal to 69 times 8, and we get 552 meters. And that's how far away the target would be. Okay, the key thing you need to know here is, again, you cannot mix Vx and Vy, you cannot mix dx and dy. You have to break them up first, and you have to remember that if you do not have a time, that is the first thing you have to solve for. And one of the easiest ways to solve for total time is if you know the initial velocity in the y and the final velocity in the y. Alright, moving on, next, question number 7.